Hello. So today we'll see actually the prime numbers. So let me write here the counting number. Then I will tell you the definition of prime numbers. So counting number, the set of natural number. We use this set to count, something. So this is contain the 1, comma 2, comma 3, comma 4, comma 5, comma 6, and it going on. So like this. So in this list, basically, so let me write here this is called the set of counting number or the set of natural number. Now, so x belongs to, for the prime I call it is p. So p belongs to n is called a prime number if p greater than 1. So it is by definition, and uh, and only divisor only divisors of p are 1 and p. So if you have a number from this list here, then that number we called a prime number if you know what, the number is greater than 1 and it has only two divisors, 1 and p. Okay, so now if a number is not prime, it is called a composite number. So now why the primes are important? Because look at this. So here the you can say the theorem that let me state here. This is very important theorem that if we take x, any natural number, then either x equals to 1 or x can be written. So okay, of course, either x is a 1 or x is a prime itself, or x can be written as product of prime. So this is very important. If you take any natural number, so say x, then either it will be a number 1 itself or it is a prime number. So if it is not a prime number, so you can write it is as the product of prime number. Okay, fine. So this means you can think basically all the natural number are constructed from the primes number. Why? Because if you take a number which is not prime, then you know that number we can always write as the product of primes. So in that sense, you can say that primes number are the parents of the composites number. Okay, like this. So let me give you an example. For example, if you take, let's say, x equals to 12, then 12 you can write here 2 square, 2 into 2 into 3. So 2 is a prime, 2 is a prime, 3 is a prime, right? Okay. So now let try to understand the positions of the prime here basically. So although people actually use this logic, the counting symbol 1 2 3 4 to count something, but it is surprising that in this counting process the hidden logic is very important. The hidden logic is very important, and the still people are trying to understand the hidden logic of their counting number systems, especially the prime number. So let me tell you one concept here about the prime number, the how the primes number appear in the natural number. So let me make a table. So let me find out here. So firstly put here 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 14, and then 15, and then 16, and then 17, 18, 19, 20, 21, 22, 23, 24, and keep going on. So let me here circle all the prime numbers. So clearly 2 is a prime number, then 3 is a prime number, 5 is a prime number, 7 is a prime number, 11 is a prime number, 13 is a prime number, and of course the 17 is a prime number, and 19 is a prime number. So 23 is a prime number. See, the observe one thing here. If you try to rearrange, or if you try to make a sequence, or if you want to write the prime number consecutively, so then you have to understand what is the next prime number. If you know a prime number, say in the kth place, then you have to understand what is the prime number in k plus 1 place. So it is very important to understand the gap between two consecutive prime number. For example, the first prime number here, p1, is 2, and p2 is, the second prime number is 3, and the, let's say this is called, the third prime number is 5, like this. So dot 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 dot, someone can ask p, this is the kth prime number. So you can think about this. So if you want to think what will be the kth prime number, if you want to write a formula, so then you have to understand, does there exist any regularity in the coming of the prime number in the natural number series sequence, basically. So that we have to firstly check. So how we can do, basically, see, observe here. Firstly, see, the gap between first two prime number is 1, and gap between then second and third prime number is 2, and then gap between third and fourth is 1, and then fourth and fifth is 3. So the gap between two consecutive prime number are not regular. So it is not gap between two consecutive primes is not regular. So regular in this sense, the gap does not maintain any formula, mathematical formula. For example, what I am trying to tell you, that regularity. So this means if you consider all even number, for example, then what happened? The even number, basically 2, 4, 6. So one after a number, you are getting a even number. For example, 2, then you cross the 3, then getting 4, then cross 5, then getting 6, like this. Then again after one number you are getting 8. So this is something, a logic. So in mathematical logic you can put a formula, that logic. But since the gap between two prime numbers does not maintain such regularity, so it's a difficulty here. So now the question here, one thing here that we have to check. Okay, so what I'm trying to tell you, basically, that one thing we will now check here, that if we know a prime, what will be the maximum gap between two consecutive prime number, that we are trying to understand. So see, if a number is not prime, this means what? That number has a factor, except the one and the number itself. Okay, so now we will understand the gap between two consecutive primes. So how to do it, basically? So let me write here a statement that allow us to, that the gap is increasing. So here, see, for example, the gap, if you circle all the prime number, you can see the gap, sometimes small, sometimes increase, like this. So if you go very the far from one, you can see the gap will become larger and larger. So how you guaranteed that? So here the theorem. So this is theorem, and very easy observation. If n is a natural number, n is a natural number, then there exists n consecutive composite number. And consecutive composite numbers. So this means for every natural number we can find n consecutive, n consecutive composite number. So in between those composite number there is no prime number. So this means that if you give larger n, the gap between two consecutive primes become larger and larger. So that is the idea here basically. So how the proof is very easy. So the proof will use the factorial process basically. So let me write here that a1 I'm writing here. So basically, okay, so not writing a1. So let's consider this sequence n plus 1 factorial plus 2. So then okay, I'm writing like this. So n plus 1 factorial and plus 3 and n plus 1 factorial plus 4, and this is dot 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 dot. So you can write here n plus 1 factorial plus n plus 1. So here observe that this number is divisible by 2. And the number is greater than 2, and this number, this is divisible by basically 3, because inside n plus 1 factorial 3 will appear, right? Of course, okay, so similarly this is divisible by 4. So similarly this is divisible by n plus 1. So every number has a proper factor. In this list every number has a proper factor, and the difference between any two consecutive numbers are 1, right? So for example, this minus this is, this minus this is 1, this minus this is 1. So this sequence contain n numbers. So this is the sequence of n consecutives number. So this means what? If you so this number actually makes the gap larger and larger between two prime numbers, this concept. So this is theorem. So basically the claim, so you can think about this. So that I'm writing here as a theorem that theorem, if dn equals to the distance between two consecutive primes, then so limit n goes to infinity, d of n equals to infinity. So this is very important. If you take the distance between two consecutive primes, then distance will become infinity. Why? Because of this theorem. Because for any natural number you can find out n composite number. So if you have here a prime number, then after n composite number you have another prime number. So this means the distance, if you increase, if you take n larger and larger, the distance between two consecutive prime number become larger and larger. So this means it is sense that in mathematical language we say the distance goes to infinity as n goes to infinity. So yeah, that was the idea, and there are many more the concept about the prime number, and prime number enjoy many more beautiful mathematical models. So that we'll see, and there are many more open problem on mathematics about the prime numbers. So we'll discuss in the next video. Thank you so much. Bye.